Yeah. Yeah, so this is the subgroup in SIG automation for package specialization on the 23rd of March. So what I was thinking for today is, because yesterday we discussed a little bit some of the, let's say, concepts on how or what we would do with respect to the functions and the controller in the specialization part. So I thought, and there was a request to see how can we build a function or a kept function. So I try to accommodate something, or I will experiment. So by far I'm an expert in kept function. So some of all the learnings that or what I will share is my interpretation of some of the stuff. But yeah, the idea is to go through that together, and then we can see where we end up. Okay. So let me share my screen. So the first thing that I did was, do you see my screen?
Yes.
Yes.
So I created a package because everything, so we in package specialization, we are receiving a package from after it is being fed out and contextualized, if you will, right, through the package variant set and package variants, right? And what I tried to do, and that was also a question because yesterday we had a slide with some of these objects, but not the details. So what I tried to do also, and I shared a link with you where you can find that thing. So if you want to do this exercise together, I propose that we clone that repo. And if you want to see the link is actually here. So basically that's the repo that contains that example. Most likely we should probably move this in. I don't know. I mean, my thought is to move this into Nepio, because we probably need to build various examples of this going forward, because I know that John was asking me for the same. I thought it was going to take a bit longer, but it went pretty fast. So what is in that package? Yeah, so if people want to clone it, please go ahead.
Yes, we would like to follow what you're doing. Okay. Thank you.
So there is a few objects that are in here. Will it be 100% correct? No, but it's like 90+% correct, I think, from what you see.
So, Wim, is there? Can you increase the font a little bit?
Yes, we can. Is this better?
Yes, thank you.
But my coding will be, yeah, so I have less of a window in that case. Yeah, is this okay?
One level more, one level up.
All right.
Yeah. Yes, that's good. Thank you.
So there is a number of CRs in here. So one is capacity. So the example is a UPF, okay? By the way, this is the proposal. I have a PR open where these CRs are actually in, so there is a PR in the API repo where this is basically aligned with that. That's of course not yet agreed or approved. So there might be some changes, but that's the current understanding on how that would work. So we have a capacity, which, so we have, at the moment, I also have called this requirement in the API version. So it's requirement.nepio.org, also not yet agreed. But yeah, so I'm using the same thing that what is in that, that PR. So it has a name. What is also important that you see in these things. Yeah, okay, Fish, you have a question?
Yeah, I just wanted to make sure I understood. So this is the specialization part,
Yes.
right? When we are looking at this, are we looking at the local package where the values have been applied? Is it where the functions have already been applied? Is it
No, no. So this is basically
still the template?
package. Let's say it's already manipulated by package variant sets and package variants. So because you see there is cluster context in here.
Okay.
You see, so it's not the blueprint. So it's actually the blueprint plus cluster context.
Oh, okay. It's blueprint plus cluster context, but we have still not applied any of the functions to.
Correct. Yeah, correct. So the idea is to build a
Specialize
function together.
Mm.
I'm not going to do the full-blown function probably, but give you, or the idea is to give you to the, let's say, the semantics of what a function entails, how you get access to these resources, how you can add a resource, how you do error handling. So that's my goal of today is,
Okay.
I'm not going to write a full-blown function, but the idea is to write a function from scratch. And the first thing that you will see is you will get access to these resources. And then we will be able to see how you can get access to the data, right? That is in here. And then if we can get through all of it, I don't know whether we will. The idea is to add or even manipulate. So add a resource that is not here yet, and see how all of that works. So that's my goal. There's a lot. So I'm not sure whether we will succeed with all of it, but that's my objective. So is that to give you, so the people that will help us write these functions, to give them a bit of an introduction on how to do so. Okay.
Sounds good.
Yeah. Okay. Cool. So yeah. So basically, so there is capacity. So there is an uplink and a downlink throughput in the spec. One thing that you see here, I don't know. This is probably not so well known or maybe understood. See, we have this package contains lots of resources. There is this annotation in here, and that is used, by the way, in config sync. To basically tell config sync which resources to apply to the workload cluster and which one not. So here you see, if local config is true, it actually means that this is config sync will not take this into consideration to apply to the workload cluster. Okay. So yeah, one is capacity. So I'll skip cluster context for now because that actually came from so that came, I was experimenting yesterday. That came from the package management. So this is actually added during I believe this will be added through the package variant. This will include that context inside of when it clones the repo or the blueprint to the next stage, it will add this. Okay, but I'll skip it for now because let's first go through the other resources. So there is data network name, so the DNN, similar thing. So what is in here, to which network instance he is connected, and the pools. So you can have pools with a certain prefix length that needs to be assigned, right? Then, yeah, we had a lot of debates, like we had this name of network attachments. We believe, we kind of agreed with some folks to change this name to interface. So everything that we have said, network attachment, and the reason we did it is because Multus also talk about network attachment definitions, and it's very confusing because this is not a true, and not all of these interfaces are going to be Multus based. And so as such, we changed the name to interface because we have loopback interfaces and we have then these virtual NICs, if you remember from the discussion on how IPs are being consumed. So we have a interface. What is in the interface? Again, to which network instance it is attached. What is the CNI that he would use and whether he needs a VLAN or not, right? Same for N4 is the same. I think the only difference that I added in this example is that the network is a different one. And for N6, one moment, Ganesh. So N6, it's similar. Yeah, Ganesh, you have a question?
Yeah, sure. No problem. Maybe it's a little bit too late to ask this question. See, from what I know, the capacity, like if we can go to the capacity.yaml, these values are not populated as part of package specialization, right? Like this 10G or uplink and downlink.
This came already from the beginning. So basically,
correct.
Yeah. So all of what you see at the moment. So yeah, what I'm trying to show here is what we get without having applied any function that we wrote yet. That's kind of what this
Right.
tries to represent.
Yeah, so I understood, like, because from a previous discussion, this comes from the first subpart, subgroup. But however, the interface and IP address and VLAN, everything is allocated as part of here. And how would we know the package capacity even before allocating respect to VLAN, or is it's not related? So this capacity not related to any of these interfaces allocation that we are doing?
The IPs and stuff don't really matter for that, right? So the capacity is typically being used here to see how many pods of a network function do I need and stuff like that. So typically we are not even at the moment we are not even manipulating it, because typically it's the vendor that will determine how their network functions should be configured to reach these goals, if you will, or these requirements. So as such, the functions that we are focused upon is not related to capacity at the moment, or at least we haven't seen a need to do so. If, for example, you would do a vendor, let's say, deployment, and for this capacity, I need 5 pods. We believe that there should be a vendor function that could sit here, or even come at the workload cluster that takes that capacity into account and determines the amount of pods and the configuration that they need to reach this requirement.
Yeah, and I'll say you could, right? It could be that, like Wim was saying, that's the desired capacity. So you can imagine that function could also be like, hey, I need a bonded NIC here, but that's getting into like the infrastructure side. So there may be some future resources we create that allow the network function to sort of make a request to the infrastructure to say, you know, create a bonded NIC or something like, but we don't have that in our one.
Yeah.
Okay.
The capacity is there basically as a placeholder because we believe we need it, but at the moment we don't do anything with it. Yeah.
Understood.
So that means in general, I mean, trying to understand this, it could be anything. The max uplink throughput and max downlink throughput could be 10 gig, 100 gig, whatever it is. That's a template, basically.
Yeah.
When it gets applied, the function determines what is really, it probably gets to know what can really be applied. You know, there is some validation it does. That function goes and updates the local config with the correct values, probably, whether it is 100 gig or 1 gig, anything like that. I know it's not in scope, but the generic flow seems like you get this resources, and then you know what function you want to apply.
Yeah, now so let's take the example. If we do it in a function during specialization, eventually, one use case that I would see, how I see it is like, say, 10 gig, I need 5 pods, right? So your deployment will have 5 replicas, right? So
yeah, I don't think the function would change the capacity values because those are the requested. Think about it like this is what the intent of the deployer is. Now, what your question, if I understand it correctly, begs is, you know, what if you can't achieve that intent? And what does the function do, or what does the controller do? Whatever, depending on whether it's a function or a controller or the workload operator, it's going to have to surface that inability to meet that intent somehow. But we have ways for each type of processor to surface errors. But we probably need to make those ways better.
Yeah, I think you answered some other questions as well. The way I was thinking was when I looked at the kept functions, like, you know, how you can go off and modify the number of replicas, you know, and where you can actually go off and for the replica count from 1 to 5, I was thinking there is a template out there. It's a generic template, but just like how I'm able to change the replica count from 2 to 5, I was thinking that the template locally, I can change the capacity from 10 gig to 20 gig. That's possible, I guess.
yes, but typically we are in an intent-based system, right? So we typically, this is basically the requirements on how the operator wants to consume it. So normally, I don't believe that this should be changed. But one of the things that we have as a use case for release 1 is people want to change this capacity. So what will happen is that the package will now potentially come with 20 gig, but it comes, so someone has changed the requirement from 10 gig to 20 gig, and that is going to then be adhered to, you see? But we don't expect, because that's, if you start doing that, then you violate the intent-based system somehow, right? Because you are going to locally change something, then you're no longer aligned with what was requested.
Okay.
You have to be mindful of that.
Yeah, we have to
I think
be
this-
careful of what's user intent and what's, so the idea is that the capacity provides a higher level API for the user to specify their intent without having to understand what that implies for the particular vendor's network function. So they don't need to know how many replicas or whether you need bonded NICs or whether you need huge pages in order to achieve that. The vendor knows that. And so we as Nephew are providing a consumer-friendly higher level API to express the intent and allowing the vendor to interpret that in the configuration of the network function.
Thanks.
Okay, yeah, maybe let's proceed, because I think, yeah, otherwise we'll never, I'm not sure whether we get, but I think we can answer these things later if you don't mind, or on the Slack or something like that. Yeah.
Sure.
Yeah. So the kept file itself, I did not put the pipeline in because I don't have images yet to consume, but there will be mutator functions here normally. So I commented them out for the time being. And then there is package context, which you get always for default, which typically is in a lot of cases not used yet, but if we use it, we could use it for this function config stuff. Okay, so that's basically the content of the package that we get for a particular cluster. And I put here, I don't know, H1 or something like that. Yeah, it's here, right? So that's kind of the thing. So now the first thing that we have to do is write a function, right? And that's, I think the first thing that we want to do is, okay, how do we get access to this data? So the first thing we have to do is initialize a go.mod file. So typically you can use, because we are not really going to use it, just initialize your go.mod. I just use example.com/foo, right? But this normally is going to be your package on which your code resides, right? And then the next thing that we have to do is we have to create a main.go file in which we are going to write some code. Okay. And in the main.go file, you initialize it with package main, and we have a function main. So that's typical Go, right? So now what the thing that we have to do is so there is an SDK of Go. So there is, maybe it's interesting for you. So there is this kept book, by the way. Yeah, it's quite a lot of, it's a lot of content in here, but it's actually, yeah, once you understand it, it's actually nice. So I'm going, so here you see developing function in the book. So I'm using that section, and there is, so you can have develop in Go in TypeScript and develop in Starlark, which is a subset of Python. It's a Python subset of how to write it. So these are the SDKs. So we are going to use the Go SDK for it. And then, yeah, so that's what we are going to use here. Now, from my experience, actually it's one SDK, but there is two ways to get access to this data. And maybe Alex, I'll show you the two options. What my experience tells you, and I'm going to clarify it, or John, maybe you know, is there is the function with context, right, which is way more abstracted. So what is happening under the hood? So what kept is doing, and this kept function are doing, you get a resource list, right? A resource list, and if you go to the Go, wait, where is the library here? So you can actually.
I'll just give a little background while you're looking. Like, I'm in the car, I can't see what you're doing, but there's a standard library that comes out of Kubernetes SIG CLI called KYAML that you can use to do all of this. And some people, at least in the KEP team, found it too painful to use. And so they tried to build an SDK that makes it simpler to build KEP functions. I'm not sure it makes it simpler to build KEP functions. Maybe it's just poorly documented. To me, it wasn't that hard to make it with the KYAML library, and just having a simple main file that manipulates YAML, I felt comfortable with without having to learn a framework. But I think, those are two options that I know of right now. We may decide that neither of those is ideal and we want a third option. I think we'll figure that out over the next, several months.
Yeah, I
So that's the history as far as I know.
I conversed on this SDK a little bit, but you have to, of course, understand how it works. But because see, it abstracts stuff a little bit. Now there is two flavors of how to use it from my perspective. And my experience tells me that one of the flavors you cannot add resources, whereas the other flavor you can. But I'm going to clarify it with the KEP team, unless you know, John, but I don't know whether you know. So
I don't know.
okay, yeah. So okay, so what I'm going to teach or try to teach, or is a big word because I'm not a teacher, but show is the SDK based. So as John said, there is a third way of, or there is another way of doing it. Is it's just consuming the resources regularly. But I found the SDK. Yeah, I mean. Okay, you have to get used to it, but
it may be better. I just didn't have the, I didn't take the time to figure it out. So it's one of those little,
so let me show how it works, right? So you have function.sMain. So that's how you consume it. And then you have, and I'll show you the other option as well. So there is a resource list processor function, right? And that contains, let's say, there is a run function. We'll define that in a bit. And then what you have to do is there is an error. Run is not defined, right? And then if it fails, you basically do an exit one. So this is not defined yet. But so this is one thing. So we'll define run in a bit. This is I call it the raw usage of the function SDK. And the reason I say it's the raw one is in this case, and maybe I'll show you a bit more on how to consume it completely. So if you do function run, and then I think it is you return a Boolean and an error, I believe. Yeah, and then return true, nil. And if you have to go mod tidy to actually resolve that SDK in the go mod file. So that is oh, wait a minute, I think I forgot one thing in the there is a resource list. Yeah, so the resource list star function dot resource list. Yeah, because you need to get
So the sMain and resource context processor function pre-processes the input that comes via standard in and does some bootstrapping and provides us the resource list then, yeah?
Yeah, so basically what happens, right, by this SDK is that these KEP functions, they work with standard in and standard out and standard error, right? So in other words, you get raw data and you somehow need to process that raw data, right? So what this processor does, as you said, Marcus, is basically parsing it for you, and it's being represented in the form of a resource list. And what does a resource list contain? It contains items which are the individual files with the respective data. A function config, if you have defined it. So in our case, we don't have it. And you have results. So if you process things and you want to represent errors or warnings or information back as a result, you can contain it. And it's those results are returned in that resource list context. Why? Because you have standard out and then you have standard error. So when you use standard error, it's actually being used to really show an error. So that's why this you see a Boolean and an error. So the error is really to say it failed, right? And then you see that we are exiting and this will be a standard error exit. Or there will be an error during standard error. If we basically, the way I try to write the functions is not to create or try to have an error unless you really have something that you really cannot deal with. You have to return an error, but it's really, really exceptional. What you typically do is if you see errors, you add them to the results, and those are represented as when the function stops, you actually see that that content. Okay. So this is the raw formats on how to use it. So so what we can do, for example, maybe let's just look at this. So the way to run this, by the way, it's what you do is kept, and this is why you need kept source, and then you source the data, you source that package, right? And then what you do is you do go run star dot go or main dot go, yeah, star dot go. So what you see right now is actually, so this is the standard so kept function source. So basically reads the content of this this directory, and with the pipe statement represents that to it. So it's actually standard in towards this function. So that's what this thing does. So I don't do anything with it. If you would, I print out and print, by the way, I'll explain in a bit. It's good when you start to develop it, but if you go to production, you have to remove it, right? So let's say, let's put here resource list or something like that. And then, yeah.
Can we not use logs? I know.
No, because see, we are
okay.
in standard in, standard error, standard out, right? So all of this thing is interpreted as standard out if you do logging or printing.
Should be fine if you write it to a file, right? And not use standard error or standard out.
Correct. So that's why the result is important. So all the information that you want to consume. So in this, so when you're developing at this moment in time, it's okay to print, right? And it's the easiest, or to log or something. But if you go to production, if you do this, this should be a YAML representation. So when you call this function in production, when you run it, you actually see this is no valid YAML when you get this. And most likely, a print statement.
There are logger libraries that actually
No. So
Okay.
remember, these are running, they don't even have file system access.
Yeah.
Right? These are running without network access, file system access. All they have is standard in, standard error, standard out. So you could write it to standard error. I don't know how kept as an orchestrator. Remember, like, customize is also a KRM function orchestrator. Porch is also a KRM. Like, these are sort of a general concept. Like, I don't know how they interpret standard error, whether anything on standard error means a problem, or whether they interpret the as a return code, and just log the standard error stuff. But in general, yeah, these are running in a with no mounts, no network access in the general case.
So it's important. So that's a very important thing to understand, is really, if you want to represent or show things that you see that failed, or you want to inform things, use result. Yes, Akash.
Hi, Vim. So when I read the documentation, it said that it is actually using container. So I was thinking like, so that means that we can use the standard logging tricks, which how we export the logs of a container. So I thought maybe we can do similar, something very similar, because these functions are anyway containerized, right? So
Yes, but so the container, so that's true. So at the moment I'm run them raw on my computer without having a container engine. But so in the container, so what you will see, if you look on the details on how Porch executes them, he has a wrapper underneath, and then you have the function which is using standard in, standard out, basically. So the function itself, you cannot do the logging, but once you get it back, you can. So the way it's consumed is that when you write into the results, the data in the results is consumed by Porch to do something with, right? So that is the mechanism to provide information of how what you achieve during your processing time, and we will show that. For example, if I say rl.results, right, because this is the data structures on which they are contained, right? So you could actually provide information in here that tells you what happens, right? So you could basically say append rl.results, and you basically say, I think, what is it? Function error, object result or something like that. And you basically say, yeah, fmt.errorf, let's say error. And I think you have to provide an object in this case. Yeah, comma rl.items 0, right? Maybe it errors out, right? I don't know. We'll see. So let's say you do this. So I run it. You see here, you get an error, severity error, message error. So you see here, so it's a kept file. Okay, it's because resource item 0 is the kept file in it. So, but here you see, this is the information that you get back. It's probably a very bad example here, but that's how you provide information back on what happened. So this is the message, which is actually this. And then you have severities and stuff like that. So I think there is a bunch of things that you can represent back to the system here. You see here config file result, config object error, and so on and so forth, right? Okay.
yeah, thank you.
Yeah. So, but that's kind of one option. So, for example, if you really want to, let's maybe, by the way, are people following, or am I going too fast, or is it okay?
That's fine.
Follow, yes.
Yeah, there is a bit of Go here as well, right? So I'm maybe, yeah. So here, if you, for example, range over resource list dot items, I think, which is items is basically the list of objects that are in the resource list. So you can actually see here, items will be the slice containing the resources into the file, right? So basically here you can access the data. And I think if you look to K is an integer, I think.
Range isn't spelled right.
Okay, sorry. Yeah, good point. So this is an integer. So typically you don't, you could use it. And this is the object itself. So this is, for example, also, so when you use the SDK, this is an object on which you have a set of methods that you can use to get access to the data. So let's maybe do that, right? So here, this is O or something like that. And then if you, for example, say, O get API version, right? And maybe we can print it, right? So maybe we'll remove this part and say, let's print the API version of each of the resources. And let's also print the get kind, right? So you see that the fields in the metadata header of the KRM, you have direct access to. The things in the spec of a KRM, you have to do some other things, but we'll get there in a bit, right? So with this thing here, so now what I'm going to do, so let's remove that result for now and just say, I just print all the resources. I print the API version and the kind for each of the resources that are in the resource list, okay? Which actually should be the same as what you see here, okay? So let's run this. Now, also important to note is that the way this works is that, so kept function source is actually also using standard out. So basically you see also what comes to the function as well. So the way to debug this always is you have to go here at the top. But you see here, so this is actually what is coming back. So we see a cap file, we see a capacity object, we see a cluster context, we see a data network name, we see the interfaces, we see the config map, which is the package context, right? And so on and so forth. So basically, this is, you see that we slowly can start getting access to the data. Yeah, Ganesh, yeah.
One quick question. So earlier, if we are not using rl.results,
Yes.
If you're not appending anything, by default, it prints all the kept results, right? Whatever you're giving in input, it prints it in the output.
Yeah, even the result doesn't matter. It does it all the time. And that's just because we use this kept function source. So there is other ways. So if you really containerize your function, this will not happen. This is the simplest way to debug. So when I develop a function, so I'm just sharing my own experience, this is the easiest way because you see you don't need containers, you just develop in your Go environment and you get information. You see, I want to access this particular piece of information. Can I do that, right? So that's kind of what I'm trying, and this is your basic developer, how I typically start. From the moment I'm happy with the result, because you will see what I'm doing right now is the first thing that you have to do is, or at least in my mind, is gather information always, right? So you always have to see, for example, what we discussed yesterday. Let's say cluster context is not there. In that case, we don't have to do anything. So that means you have to, for example, figure out did this exist or not, and if not, we basically have to skip everything, right?
Okay. So the summary is like, if we containerize it, then it will not print everything. It will just print the API version of all the kinds from whatever.
Yes. Now one more thing. So how I do it, I'm just sharing my own experience, is I develop this way. I print things out. I see whether it's okay. And at some point I have the right result. Okay. Then the next step that I'm doing is I'm containerizing. So I'm building this image and I'm building a Docker image from it. And then I'm running it through, I think it's kept function eval. And then you say, execute this container. The real syntax is, let me share. So it's kept, and I'm going to write a bit of a tutorial, but it's my own for you guys to help, but I couldn't do it at this time. You say, I execute a mutator function, and then you say, please look at the data file. So you basically say, this is the data that you data / package UPF, right? So you say what data you should represent to this function, and then you say -i, and then you have your Docker image. If you do this, it's the same as if you execute imports. So this is really now so that's why I always develop in two phases, because you typically have to figure out how do I get access to the data, and develop your function a little bit, do your robustness checks, and you build your developer environment. Then I containerize the image, and then I execute it in this way, and then you're actually, yeah, you actually have it in the same way as it would run within the port context. But in this mode, if you do a print, right, you will have you will get errors that you have YAML, that a print statement like this is not valid YAML. So you get errors like that. So all the print statements you have to remove when you go to that stage.
Yes, understood. Thank you.
Okay, so now, by the way, so this is my preferred way of working, because in the other, so there is the other mode that I can show, because the I can maybe I don't know whether we have time. Yeah, do you guys want me to show the other method, or we continue on this way? Because
No, let's continue. I think I'm okay.
Okay, fine. So then, for example, yeah, what are the things that we can do? Let's say we want to, what you see, for example, is what you saw so far is that all the metadata in a spec, so in a KRM, so everything that is here, you have straight access to through this function. Now, what if you need to get this name of this network instance, right? That is not standard, that's KRM, but that's not metadata, or that's not in the header of the KRM thing. So here you, so that library, that function SDK library, give you some tools to access data. So what is this type? Function object. Okay, so normally the way you access that data, I think, is get string, I think, or nested string, I think it is. And I think then you say spec. Yeah, first of all, we have to, I'll correct it in a bit. Then it's network instance, and then it's name, I think. Now, of course, if we execute it like that, this should only be done if the API version is this, and if the kind is interface, right? So what we typically do is, because here we loop through all the items, then you say if o.get API version equals, I think that's what it is, and so the object / get kind equals interface, right? Do this, and this should give me a name, right? And I could print out, for example, first line with a capital, and I say interface name, network interface network name, right? And we could, what's wrong? Yeah, okay. Yeah, the problem is that the return here of this object is a string. So it's network instance name, okay, and an error, right? I think, yeah. So that's what you get back. So what you typically do if you get an error, then what I typically do is rl.result, or l.result is append rl.results, and then I say function dot what you saw before, error object result. You contain the error, and you say this is the object on which that error resided. So, and if there is an error, you will get that back from yeah, in the result part, you get that back. The OK will tell you, so that it can be two things. Either the processing is really, there was an issue, but it's not because there is no error, that actually that data is valid. So what you typically have to also do is, if OK, then you can print the data, because it's only valid when that when that was basically the result. So that's typically the way to do it. What we can do as well to make it a bit better is to say, oh, let's say we also print out the name of the interface. So that makes it a bit easier, right? So with this, now we should say for this interface, we should get the respective network instance name. So let's execute this. Maybe I should clear my screen. Because then we can go to the top. So what did we get? So you see here, yeah, okay, I'm still printing out this part. So maybe I should remove it. So you see, this development is rather, when you start, it's actually straightforward to do in my eye. So that's how I personally start. And you now see that we got for every of the interfaces, we see the respective network instance name. All right. Okay. So, so that is one thing. Now, so what did we do? So you see that how to get access to data. Yeah, of course, there is more complicated scenarios. For example, you can have a slice. So if you take, for example, DNN, let's say you want to get access to this pool here, right? And you want to, because this is a slice of, so there can be more than one inside of it. So here you actually, what is the way to do that again? So again, what you also see back, and by the way, so also very important, I never use this syntax, but it's very convenient when you start developing. But the problem with this is that if at some point we change our API version to something else, this will no longer work, right? So my preferred way of doing this is that we use the API library. So there is, so if you take, for example, and I don't have it here yet, but if you take core, let's say that this imports core v1 library, you can get access to schema group version dot identifier. And this will give you the same API version as this here. So in other words, you actually use it from the origin where it's defined rather than doing something by ourselves. And you can do the same for the kind. So that is a similar function I can share afterwards to get access to that kind information without actually formatting as a string. So then you actually get it from the CRD source where it's defined, rather than doing like this, because otherwise if we do some changes here and so on and so forth, you will be creating issues.
Probably should be some sort of metadata way of selecting these things in a full on industrialized system. This is great for illustration purposes.
Correct. Yeah, this is the easiest way to do, because you just copy it from this thing and you're done, right? But I would try to avoid it, because it might not be the best way if we do changes. Normally these things don't change very often either, but that's again my personal preference. So let's say what I was trying to show you is a more complex scenario. Okay, so that's the same, and then it's how did that kind? It's this, right? And now I said let's get access to that pool here, right? So what you have to do, or how I do it, or one way to do it, is you say you get a nested slice, nested What is it again? Not a string slice. Nested slice, yeah. And it's spec, and then it is, what was it? Pools, right? So you first want to get access to the slice. So this is actually pools, right? You see the same thing. So in this case, what you get back, you get sliced object back. So this is a slice of sub objects. And then what you do is you because this is again a slice. So now you basically go through all the pools that you have, right? And now what you can do is you basically say, so this is TNN, and you basically print out the pool. Okay, and here you have to go back. So you pool, what is it? Let's say we want to have the name, right? The name, but it's again, okay, comma error, and then pool dot get string. And then you say name, I think it was. Is that correct? Okay. So here I got it directly. I got it straight. Okay. They don't give because it's either there or not. So if it's not there, you will get a 0. Okay. I'm just going to run this, but yeah, ask your question.
I notice you're doing this in main.go.
Yeah.
Is that because this is an example and not actual?
Yeah, so a good point, indeed. So what I normally do in my developer, how I develop it, I remove this from main.go and I build this. And we will do that. I'll do that in a bit. So let's do that after this. I typically put that in a separate subdirectory and so on and so forth, because depending on how complex your thing is, it can become a big file. So I rather split it up. But yeah, indeed. So for me right now, it's really just to show the principles, but I'll do that in a bit. Okay.
Okay, thanks.
So I cleared this out, and then if we run this again, and okay, you always have to go to the top. You see, we got DNN with name internet, and it has one pool. So you see, this is how you can get access to the data. Also, I would like us, we are getting the CRDs in play, because what you will see is that in the regular functions, you potentially need to get access to the same data, right? So that it's stupid to always do it for every function, do the same. So I would like us to build a library as part of the CRDs that various functions can access to the data, such that we don't have to repeat this parsing all the time, right? So one of the things that I would like to do also with our team is that once the CRD are in place, that we start writing these libraries to get access to that data, and that we can reuse that in functions. Okay. So now towards endpoints is, and I don't know whether you agree, but normally it's not so good to actually have that here. So what I typically do is, and I think Fish, we said it has to be a mutator, so we'll follow your guidance. And we say, let's add that in a mutator.go file. And then we say it's package mutator. Mutator. Of course, oh, sorry, mutator. And now we just have to do mutator.run. And we import it. And this is basically the way to split the thing, right? So if we run it again, it would be the same thing. Okay. Now, one more thing is that you see that this can become already quite big, right? And this will grow and grow and grow. So I'm always of the, what I typically do as well is, because what you also see is you will need context, probably. So for example, in one of the functions we say, is the cluster list does the cluster list exist or not? So what I typically do as well is I create, let's call it mutator context for now, which is a struct. Let's keep it empty. But what I then normally do is I create a method on this function. So like, yeah, I always do R, or maybe we can call it M, and then say, let's call it gather info, right? And you also give this the resource list, for example, and you say another function is the real mutation, right? Mutation. So that's the second function. So what you would do now is you basically add this here, right? So now this is becoming your mutator gather info. And what you do is when you do the run is you say, so you create a mutator context, which is like this. And now you do m.gatherInfo, right? And you give it a resource list. Okay, you could also give errors and stuff like that. I don't do it a lot, and you could then also call m.mutator, mutation, right? So you see now your code becomes more structured, and you can put this in another file and stuff like that. So for example, let's do a quick test to say cluster context Boolean, right? So did it exist? So how to do so is you basically go here, you look at cluster context, you check the API version that resembles it, you check the cluster context resource, and if this is okay, what do? You say r.cluster context equals true, right? So now if you go to the mutator function and you do if r.cluster context, then you process mutation, otherwise you don't. This is the way to do it, or this is a way to do it. You see, but now your code becomes more structured. Yeah? So I think we are running out of time. So I hope this was helpful. On Monday, what I can show you is how to add a new resource. Okay. But yeah, I think, is there any quick questions for now, or was it useful, by the way?
Yeah, very useful. Thanks, Prem.
Yeah, absolutely. Very good. Thank you.
Yeah,
right.
thank you.
So one question is in the base package, if I may ask that question. So in the base package, is there no YAML related to UPF at all? Just so.
Not yet. So okay, at the moment, not yet. So that's one of the things that we are still discussing. But normally, one of the last function, it will create UPF deployment. If you look to our flow, so that's going to be the thing, and then you see very specific UPF stuff. And we are debating whether we need something somewhere, some information, maybe that this is for UPF or something like that. So there could be somewhere a label or an annotation that is somewhere that we consume to know that it's a UPF. But we are still, I will be discussing that a little bit still.
Okay.
All right. All right. Thank you for your time, and we'll be in touch.
Thank you.
Yeah.
Time for TLC.
to him.
Thank you.